Okay, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you. At the first, the Excellency Mr. Supomo, Magister of Science, as the head of Region 3 APDFI, and Dr. Cikra Ihda, Magister of Science, as the chairman of this international conference, and the honorable of the participants today of this international conference of pharmaceutical research and practice, or we can call it ICPRP today. And I'm Erna and Mr. Aci, your moderator today. At the first, I am very pleased to see all of you and welcome you to this conference. And today we have 2 sessions and we have 4 speakers. Our speakers is Apoteker Dr. Anda Yusmaniar Magister Biotech from Poltekkes Kemenkes Jakarta, Indonesia. And our second speaker is Professor Dr. Ramesh Goyal from Delhi Pharmaceutical Science and Research University, India. And the third speaker is Association Professor Dr. Mogana Sundari Rajagopal from Faculty of Pharmacy UCSI Malaysia, and Dr. Viranut from World Union Herbal Drug Discovery from Wailala University, Thailand. Okay, today we will have 2 sessions. At the first session with Mr. Aji or Mr. Rahmat Aji Prasetya. Okay, Mr. Rahmat Aji Prasetya, I think this time is yours.
Cek. Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and thank you to each and every one of you for being here with us today. In these sessions, we will hear 2 talks from our incredible speakers, and it is my great pleasure to introduce the first one, Apoteker Dr. Anda Yusmaniar, Master of Biomedical. She is now a lecturer and also a head of the pharmacy study program at Health Polytechnic Kemenkes Jakarta II. Beforehand, she was appointed as a vice director in the same institution. She obtained her master degree from the Medical Science University in Indonesia in 2009. In the last 5 years, Mrs. Yusmaniar has published many articles, books, and presented her research at several international conferences in Dubai and Gold Coast, Australia, within the field of clinical pharmacy. Today, Apoteker Yusmaniar will deliver a topic about patients' education and medication adherence. For online participants, you may drop your questions in the chat box or use the raise hand feature after the presentations. So, without further ado, please welcome Dr. Anda Yusmaniar, Master of Biomedical Science. The floor is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. This is good morning. Good morning all. I'm honored to have the opportunity in the first APDFI Regional 3 International Conference on Pharmaceutical Research and Practice 2022. And I'd like to thank the organizer on this meeting for inviting me here today. And it's good to see you all. Thank you for coming. My name is Yusmaniar from Poltekkes Kemenkes Jakarta II. Today I'm here to provide you a topic of clinical pharmacy with the title Patient Education and Medication Adherence. Okay, before the topic, I'd like to highlight about Indonesian health. The next. Okay. My topic is about Indonesian health, about medication adherence and patient education. Boleh saya? Oke, boleh pakai. Excuse me. See? Yeah, I'd like to. Baik, okay. First, I'd like to highlight about Indonesian health system. And Indonesian health system has a mixture of public and private provider and financing. And the regulation are arranged in hierarchy from law to different level of regulation at different level of governments. And the regulation of provider includes requirement for individual provider to be registered and gain a license to practice, while a hospital required a license to operate and must participate in a hospital accreditation scheme. We know health status in Indonesia is increases about indicator of life, indicator overall of health status in Indonesia have improved significantly in 2 decades, 2.5 decades. Like we see at the screen, life expectancy in Indonesia in 1990 about 63, but in 2012 up to 71 about life expectancy. But Indonesia overall indicator increases, but non-communicable disease such as high blood pressure, high cholesterol, overweight are increases. This is we can see in the table. Communicable disease decreases from 1990 to 2010, but non-communicable disease increases from 35.9 to 55.6. And according to the latest published of WHO in 2020, stroke is the highest. Stroke is the highest cause of death among Indonesian, about 21/12 of all death. And almost risk factor of stroke is hypertension, smoking, and hypercholesteremia. And in pharmaceutical, in pharmacy, especially pharmaceutical care, government has role and responsibility to ensure the accessibility and affordability of pharmaceutical as well as the rational use of medication. Since implementation of GKN began 1 January 2014, patients insured by GKN are able to obtain medicine from healthcare facility free of charge. There are 2 existing drug lists in Indonesia in National Health System. First, National Essential Medicine List, we call it DOEN, serving as a base for medicine procurement, and the National Pharmacology listing the medicine that should be available in healthcare facility as reference to be used within the GKN system. Next, we go to the topic about clinical pharmacy. Scope of clinical pharmacy is so many, and my topic and my title about pharmacy education and teaching, especially about patient education and medication adherence stuff. Before that, we take clinical pharmacy is a practice of pharmacy as part of multidisciplinary health care team directed at achieving quality use of medicine. The quality use of medicine itself, so many definitions. The definition from WHO, quality use of medicine, patient receive medication appropriate with their clinical needs. In those that meet their own individual requirement and for an adequate period of time and at lowest cost to them and their community. and Australian national medicine policies define quality use of medicine as selective management and suitable medicine wisely, and using medicine safely and effectively. But we know drugs don't work in patients who don't take them. We have to adherence to therapy, and medication adherence is one of the important aspects of the quality use of medicine. Adherence itself is the extent to which a person's behavior of taking medicine, following a diet, and executing lifestyle change correspondent with agreed recommendation for a healthcare provider. Medication, why we have to adherence? Why we have to adherence? Because poor adherence is associated with negative clinical outcome of the disease, and many articles said that about 50% of treatment failure are due to poor medication adherence, and this results in substantial in morbidity and mortality. Medication adherence itself is patient conformance with provider recommendation with respect to timing, dose, and frequency of medication during the prescribed length of time. And success of the treatment depends on effectiveness of the medicine and adherence to therapy. And pharmacists and pharmacy technicians ensure quality of use medicine by patient. Okay, in line with this, professional pharmacy practice in many countries include patient information, patient counseling guidelines, highlight the pharmacist and pharmacy technician responsibility in ensuring the safe and effective use of medicine by consumer. To improve adherence, need patient education. To improve adherence, need patient education. And the concept of patient education is to train patients in skill and self-management to their chronic disease by adapting to the treatment of lifestyle change. Despite improving in patient skill and self-care by providing information about the treatment, patient education could enhance the empowerment and medication adherence. Patient education could reduce medical expense in long-term care for both patient and society. Okay, patient education, educating patient about their medicine or the disease, and it needs health literacy. In provision of information, support counseling or written information could be clear, understandable language, correct level, correct amount of information, and of appropriate content. Education for patient, the benefit education for patient would be reduce error in medication use, reduce non-adherence, awareness of adverse drug reaction, reduce adverse drug reaction, reassurance about the disease, about the medicine, additional explanation about illness, assistance with self-care, and reduction in healthcare costs. And benefit patient education for the pharmacists, pharmacists and pharmacy technician, it would be a legal protection, maintain a professional status, increases job satisfaction, attract consumer, and increases revenue. Improve increases patient and pharmacist satisfaction would improve medication adherence. The next about factor influence the adherence. Factor influence adherence. It could be health system, social economy, therapy, condition, or patient itself. And the topic we talk about patient, how to approach patient to make patient adherent. First, education, motivational interviewing, address specific barrier, self-taking training, and making taking a medicine as a habit. About the education, we know bahwa education about indication of drug, reason for taking the medication. We inform about the effectiveness, what patient should expect about the medication, and we can inform patient about safety. We talk about side effect of the medication, or maybe there is interaction of the medication, and we inform about adherence itself. Adherence would feedback would related with cause, with maybe adherence because the patient have a problem about swallowing, or maybe adherence because the patient doesn't know how to take or how important the medicine itself. And in motivational interviewing, we have to facilitate patient sharing his or her story with active and reflective listening and positive affirmation. We have to explore important and build confidence. We have to make a scale, 0 to 10. Scale for like how important to patient to take the medicine. If they say it's not important for me to take the medicine, we call it scale 0. If it's 0, patient is not non-adherence, and the scale of they know they have to take the medicine we completely and confident to take the medicine. We have to explore important and build confidence patient to take the medicine, and we have to understand the patient story. We have to understand the patient's story about how they understand about the disease, how they understand about the treatment. And the third about we have to know address specific barrier why patient not adherent to take the medicine. Some patient need exposure treatment. Maybe they phobia about the taking pill. Maybe they have some behavioral hurt, the different behavioral hurt, and we have to help patients set reminder if they are forgetful. We have right now there is a smartphone application. In the smartphone application, there is an alarm or list to do or application from Play Store or Google Play Store or any kind to help patient reminder their medication. And we have to train self-management training of patient. Patient get the list to monitor their medication, the result of medication. They assess what the result of medication and the goal they want to take. Example, blood concentration. They want to make it 100. If they achieve the goal, they have to make a reward by themselves. And if the goal is not achieved, we have to make patient to make a plan ahead to take the medicine with the adherence. And we have to taking a medicine a habit for patient. Help with organizing medication, example with box, or encourage patient to store all medication together and offer the children. Engage social support like family and friends to help organize medicine and remind patient, and attach the timing of taking medicine to existing habit like with breakfast, with when brushing teeth, or before bedtime. And there is some article about how intervention of pharmacists improve medication adherence. Medication adherence after intervention of pharmacists up from 67 to 78 in patient, in percent. And about my article from 2 years ago, we research about medication adherence and tuberculosis treatment outcome in patient HIV with tuberculosis. And the result is patient adherent have successful outcome, but patient unadherent or non-adherent high failure of treatment. And statistic said medication adherent 5.6 times greater effect to patient HIV with tuberculosis comparing with non-adherent. And the second article we talk about medication adherent is we make application of a reminder. We call it AMINO, alarm minum obat, or in English drug alarm application. And the application we have the application we made improve medication adherence in hypertension patient. The statistic analysis showed that there is a significant difference between the level adherence to taking medication in the pre and post test with the patient taking drug alarm application. Okay, as the conclusion, we talk about the pharmacist role. The pharmacist role in patient education is verify that patient has sufficient understanding and knowledge and skill to know to follow the medication regimen and monitoring plans, and patient role to adhere to their medication regimen, monitoring for drug effect, and report their experiences to pharmacists or other member the healthcare team. Thank you.
Okay, thank you for your presentations, Apotheker Yusmaniar. Now we have approximately minutes for Q sessions. So I will start with participants in these rooms. Is there anyone who want to address a questions to our speaker? Anyone? Yes. Bisa minta?
Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. I am Dr. Mintoro Sumego from Poltekkes TNI Adi Sucipto, Yogyakarta. I want to talk to Mrs. Yus. I have education about pharmacy in aviation medicine. I want to talk. The aviation pharmacy is one from interesting for discussion because many pilots to use the medicine, and he know the effect of the medicine. I want to comment from the speaker. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Kira-kira kalau bahasa Indonesianya mungkin saya di Poltekkes ini misinya adalah untuk farmasi aviation, farmasi dalam penerbangan. Banyak sekali pilot yang menggunakan obat tanpa pilot sendiri mengetahui akibat obat apa yang dia alami di dalam penerbangan. Tapi dia sendiri yang minum obat untuk penyakitnya, tapi dia tidak mengerti akibat obat yang diminum. Mungkin ini bisa jadi ke depan adalah sesuatu yang menarik untuk didiskusikan, karena di belakang pilot itu banyak banget, ada 200 orang di belakangnya kalau terjadi kecelakaan. Kira-kira begitu mohon tanggapannya. Terima kasih, selamat pagi.
Yeah, thank you. Is there anyone or the online participants? Please, would you? Okay, sir, please. Can you pass the microphone, please?
Izin Bapak Ibu. Ibu Yusminar, your presentation is really nice and very clear. I have one question. According to your presentation in the beginning, that Indonesian people about life expectancy from 60 years old in 1990 to 71 years old in 2020, right? Let us know the step to do so in detail. Okay, thank you very much.
Okay, I think in this first part is enough for 2 questions, and I let Mrs. Matiar to answer.
Thank you. About aviation medicine, there is a little article about aviation medicine, but aviation medicine is, especially aviation, is make disease rapidly spread. Okay, but the specific of medication in the highest and in a high, in the sky and on the earth, the effect maybe it's different, maybe, but it takes some research, more of research. If they take one pill of maybe some antihistamine in antihistamine on the earth and on the plane, what the different effect? What the different effect? It's interesting, yeah, for the research about aviation medicine. Yeah, the aviation medicine. I don't know much about the aviation itself. Yeah, the definition aviation medicine, but maybe it's the same, or the medicine is not in aviation, but the higher the attitude would make a different effect, like the food in the sky, but if we take it at home, it's so strong, salty, but and the sky, what the food is no taste at all. It look like that. Maybe medicine look itself, but if it we call it the medicine we take to our body, the specific metabolism for the medicine itself, it's regularly, it may be same with other, but it have to research to to know about it. Thank you for taking idea about aviation medicine. And the second about yes. Tomorrow pilot angry in Turkish Island. Turkish Island. Case from pilot of lion. Okay, and about Indonesian life expectancy. Yeah. Indonesian life expectancy of life from 60 to 70. I have it from WHO. Yeah, not our research, but I have it from WHO. The report Indonesian health system in my reference, maybe nggak kelihatan lagi ya. Nah, ya oke. WHO Regional Office for South Asia, the Republic Indonesian Health System Review. It WHO 2017, 2017 volume 7. We can see all of Indonesian status of health, of any kind of health. There is review report in WHO itself. Thank you.
Yeah, we still have 1 minute left. Is there any? No? From the online participants, is there anyone who still have curiosity to our speakers? No? Okay. So thanks again, Mrs. Yusmaniar, I'm sorry, and give a big round of applause for Apotheker Dr. Randa Yusmaniar, Master of Biomedical Science. Thank you. You may return. Now we proceed to our next speakers, Professor Ramesh Goyal from Delhi Pharmaceutical Sciences and Research University. Professor Goyal, are you there? Okay. So before we continue, I will introduce our speakers. So Professor Ramesh K. Goyal from Delhi Pharmaceutical Sciences and Research University. As a scientist, Professor Goyal has published almost 400 articles and about 40 books and book chapters. With his expertise in pharmacology, pharmacokinetics, and drugs discovery, Professor Goyal has received 76 national and international awards. He has been appointed as a fellow of 8 professional bodies and the president of the Indian Pharmacological Society, Society of Pharmacovigilance India, and the Indian Society of Hypertension. Recently, he has developed an Ayurveda formulation for the treatment of COVID and post-COVID-19 complications. Today, Professor Goyal will deliver a presentation entitled Biomarker-Based Drug Discovery with Reverse Translational Approach. Good morning, Professor Goyal.
Good morning.
Okay, so your voice is loud and clear. So are you ready to take over the screen and the floor as well?
Am I clear?
Yeah, it's very clear.
Okay.
So it's now all yours.
So can I have my screen shared?
Yeah, please.
You have to enable the screen sharing, please.
Yeah, please.
Can you allow my screen to be shared?
Yeah, please wait a minute.
Okay.
So, can we share screen from ourselves? Then you can talk.
Okay.
Yeah.
I think from your side it is not there. Okay.
Yeah. Okay.
Okay. I want to have my presentation. Hello.
Yes,
Can
please.
I have my screen? I mean, I will share the screen.
Okay. Yeah.
My screen, please. Not this. Can, no, can you allow my screen to be shared? I will operate myself.
Yeah. We having difficulties of making you as a co-host. Please wait for a minute.
So that was little older version. I have made some corrections. So
Yeah. Okay. We understand that, and we're still trying to make you as a co-host. Then you can share your screen.
okay.
Okay.
Right. Good. Thank you. Okay, can you see my screen now?
Yeah, it's very clear. Yeah.
Okay, and is it moving? Changing?
Yeah, it's changing.
Can you see the change? Yeah, it
Yeah.
is changing, no?
Yes.
Right? Okay. Salam alaikum to all and good morning to all present. I am thankful for allowing for the invitation I got. Well, my topic is going to be totally different than what has been given before. It is more of the clinical pharmacy, and I must compliment the Indonesia, the organizers for such a wonderful work they are doing for the profession of pharmacy, wherein they allow the patient compliance is getting increased, the outcomes are changing, it is apparent from what the results were presented before. But what I am going to do is now something which is it is related to the drug discovery and how to utilize the natural resources which we are having, the Asian in particular, that we have a rich resources of herbal drugs. So how to explore them? So I was there in the Malaysia. I have been appointed as the distinguished professor, and I'm thankful to Dr. Mogana, thankful to Dr. Virano, who is taking lead in this direction for having more drug discovery also. Well, I will start with something, the topic which was given to me, the biomarker-based drug discovery, and also the using the translational research. Now, biomarker is a very simple thing to begin that way, that any, what will we measure in response to medicine or during the disease, that becomes the biomarker, and that's what we mean. It can be of different types, surrogate that you have as per the regulatory agency or diagnosis. So whenever there is a disease, you have various biomarkers. Simply, see, biomarker doesn't mean a very high-fi like genomics or like that. It can be simple glucose measurement or something therapeutically, how the disease like in diabetes, when we have glucose but also the lipids, how they change. So like that, they are all biomarkers. But with the science, we have come to different genome-based biomarkers also, molecular markers. And based on that, the drug discovery is done. These are some of the examples, but what is the importance is that many times we may be good, we may be trying to see that patients having the habit of taking drug regularly, in my previous speaker has given, or something, the outcome, like in tuberculosis, the outcome was better if there is a proper adherence. But many times, in spite of that, the response is not seen. One of the reasons may be that there is a genome variations, personalized medicine, what we say, or precision medicine which has coming through, that there may be genomic variations. What is effective to one may not be effective to other. So, slowly this thing is also getting it, that based on the other parameter, you can judge whether the drug will be effective or not. So this thing is taking its time. These biomarkers have another application. The another application is that they are important even from the regulatory point of view. They are important from the clinical drug development. So at different stages of new drug discovery, these are important. So this is what the biomarkers makes it important. See, the whole world has been changing. We have seen how the world changed with respect to everything, I will say. Whether it is a source of drugs, herbals, the major source before 1900, and today genome-based drug discoveries are becoming important. Regenerative medicine is becoming important slowly. So, and then after COVID, again the things have changed and it is going further and further. Now, the symptomatic, like even the diagnosis previously used to be symptomatic, but now it is becoming genome based. That is, or more, more and more new diagnostics are added. A pharmacist is again supposed to know even that. Well, we all know this is going on. I am basically a pharmacologist also. So as a pharmacologist, I have seen a large number of changes. That every 10, 20 years something changes. When the Human Genome Project was there, it was genomic revolution and then omics revolution. And accordingly, the method, the strategies of drug discoveries kept on changing. Today, when we talk of the disease or the new drug discovery, you have to start understanding the disease. Like in COVID, what was the cause? What was the understanding the disease was very difficult. But once the understanding started, the treatment could be given. So this is what it has been changing. Like I have been more into the drug discovery, not in the clinical, but everything is important. Even the clinical part is also important. So initially when the drugs were discovered, 40% of the drug used to fail because of the pharmacokinetics. Now that is very important. A drug, because it is not reaching at the site or the metabolism is different, it may be failing. So like that, but soon the companies, the drug discovery institutions, they started this department called the Drug Metabolism and Pharmacokinetic Department itself. And then slowly this went down from 40% to 11%. But then efficacy became the problem. And so likewise that now the markers, based on the biomarkers, then the efficacies were there. Then shortening the time to have a drug discovery. So these were the challenges. Now today, if we still see, the drug discovery is more genome based, genetic ways, like how the disease process. So it starts with the biotechnology, that what is the site of action, what is the molecule, what is the target molecule, and accordingly the drugs are designed. And before this is done, I mean, this is purely the genome based, and then the animal studies start. We say preclinical safety and efficacy, followed by the phase 1, phase 2, phase 3, and drug goes into the market. Now, this approach also got little bit reversed. I mean, previously, a chemist will synthesize herbal or person or the traditional medicine will give the plant, and then we will do the extractions and all that, and finally come to the drug. So this approach has also changed. The current, like everything starts with the bioinformatics also. I will give with this example how we can do this also. Now, when, I mean, this based on the pharmacy, what I was talking, I mean, the previous lecture given. Now, what happens that, okay, the drug has already gone through this. You can see, let us see, the drug was discovered, preclinical, phase 1, phase 2, and the drug is in the market. Now, when the drug is in the market, a pharmacist starts reporting also that no, there is something wrong with the drug, or some patients are responding, others are not responding, or it is possible that some adverse effects are there, and these adverse, based on that, what we say personalized medicine, we start doing the analysis such that we may find out that a particular drug is not acting because of a particular enzyme deficiency, or like slow acetylators and fast acetylators, and we know that what is the genome there. The EGFR, like for the anti-cancer treatment, we may know that, okay, her positive, her EGFR positive or negative, and based on that we decide. But the moment we know that it is because of the other some target, that target is explored, and the drug, what we say, goes into the reverse translation. We start rediscovering based on that particular target. So this is also another thing which is coming up. Now the question is that on one side I am talking this hi-fi, you can say genomic and all that, but what about traditional medicines which are prevalent, or herbal medicines? That means we cannot do also. Now, see, what happens is that herbal versus modern. I mean, say whether herbal means it can be Chinese medicine, it can be Ayurvedic medicine, Unani, Siddha, and all that, homeopathy, like that. But many things are not known, and on the other side, everything is clear in that, and there are all regulatory mechanisms. Regulatory procedures are there. So I have seen this transformation occurring. I mean, initially when we started, it was herbal, isolation of the compounds. These compounds were explored by the modern science to give more and more drugs. And then, you know, all analytical things and everything started. To me, it was a revolution occurring with the herbal. Now today, the discovery is a reverse translation, what we say, or the reverse pharmacology, we say, and you are trying to have a drug discovery based on the reverse translation. That's what I would like to tell. So, I still feel that no, our herbal wealth, what we are having, various herbs, biological ovation, or the traditional medicines, they can be explored. But we say, think on the genetics, pharmacogenomics, but see that we stick to our traditional medicines also. So, like how I will differentiate this? See, classical approach is that we used to have some Ayurveda, Unani, Chinese, whatever we may have. We will go for extractions, then try to have activities studied, and then you finally go to the clinical trial. Now, in a reverse manner, if you already know from the traditional medicine, traditional literature, or from the local need, you can directly go for clinical observations and clinical trial exploratory. And based on that, you design new drugs. So these two approaches have been different. Now, so what happens that if we go by a traditional method, what we talk, target to clinical trial, it may take 8 to 10 years. But if we go from the trials to this directly, it is reduced, the period. Now it is 4 to 5 years, but it is within 1 year also you may get. And I will again show with the example. Well, I still feel that no, there may be all genomics and all that, but it is important. Like there was a case, I remember in 96, and he suffered from myocardial infarction, severe heart attack. The intervention showed that it was 100% block. It reduced to 45, but then it got reduced to 30 also. The patient undergoes bypass and even the surgical ventricular restoration. It was a peripheral vessel disease. See, what happened is that once he was showing me, it was found, as a pharmacist, we found that all of a sudden his heart function, which was 30% left ventricular ejection fraction, increased suddenly to 45. I was surprised. Now, he showed me that he had a traditional medicine, it was a homeopathic medicine, and I could see that because of this homeopathic medicine, he got the results. And one of the constituents was crataegus. This study, we did the study further and we found it is the wonderful drug. What I am trying to say here is not for the cardiac or anything, but from the herbals, we can definitely have powerful. Now, we all know digitalis, but spoken to digitalis. We cannot ignore even after hundreds of years of use. Still digitalis is required. So this is what, like we did couple of studies and I was happy. Same thing happened with another anti-diabetic drug I worked in my life. Anicostimalaterally, gentianeship family it was. It was used traditionally. Now, with the activity-guided fractionation and all that, I went again to the clinical study first, and I found that yes, patients were improving by that traditional medicine. And after 5 years, when I studied again, the patients who were taking, they were better controlled than those who stopped. I mean, the second column here is the patient who stopped taking that traditional medicine. Their glucose levels started to go up. So it shows that even after 5 years, it was effective. And I could correlate, I will not go into detail because I want to give one more classical example in the COVID, how we went to discovery with the translational approach. See, the drug was such that herbal, the anicostimalaterally, that the DNA damage was also prevented. That means the drug is having a long-term effect. That was I wanted to tell. Well, one of the company agreed to relook, and they allowed us to use the Zucker phosphorides. Well, when we compared our results with the pioglitazone, this was our medicine, traditional medicine, the compound which was isolated, sodium versus the pioglitazone. So they said, sir, your drug is not as effective as the pioglitazone. Well, they were right. But to me, I found that there is something more. And after long studies, I could make out that there are two things in the herbal. One was that anicostimalaterally, One was that anti-diabetic and other was anti-obesity. Now we went on studying and we could find that that herbal drug had distinct actions on different targets. What I am trying to say that if the traditional medicine which are there or herbal medicine, if we have approach from the modern science learning also, it makes a difference. Now this medicine was effective in heart patients also. And I could find that acetyl-CoA carboxylase was affected and it was improvement. Adiponectin, the differences were seen with the compounds were there. These were shamarate. What I am trying to say again in short, I don't want to confuse with all these things, that the traditional wealth which is there, see, we cannot stop the science going up. Science is definitely very important and learning more and more is also important. But if we combine the two, things are going to give wonders. That's what we always discuss. And so again coming back that now when we have this bioinformatics to the drug candidate, previously it was functional study and that. So this is what is the translational or reverse translation. So what I'm trying to say is that translational word will mean that based on the traditional medicine, we are translating it with the help of the biomarkers or with the help of the modern science or understanding the pathology, pathophysiology of a disease, you can make wonders out of the plant or out of the various traditional medicine. This is what we are trying. Now, I will just end with the 10 minutes, 10 minutes I will take only for what we did in the COVID time. COVID started precisely in 2020. And you can see our paper coming in. What happens that we tried to understand it first. I mean, patients were dying, so we followed their cause and studied those patients. What could be the cause of the death or like that. And we could find that it was clear correlation between renin-angiotensin system. Of course, slowly, by that time, within a couple of months, I mean, see, the first case was in December 19. In India, it was January 2020. And by April, May, we were clear that, oh, there is something like renin-angiotensin system. We also published the paper in that. And the enzyme, the target was also identified, and that was the renin-angiotensin converting enzyme 2. I think by now, after 2 every year, the entire, I think, audience also may be knowing that it was angiotensin converting enzyme 2. Now, to me, I mean, I am 45 years in experience in the pharmacology, so I am recapitulating all what I learned from that because I was more involved in this renin-angiotensin. See, in 50s, 60s, it was only for sodium, potassium, the kidney part. But 70s, we all knew that it became anti-hypertensive drug from the renin-angiotensin system. We got cardioprotection, the ramipril and enalapril and all that, they had a cardioprotection. Retinopathy was also there. Now, AC2 came in 2002. Nothing was known at that time. But when the COVID came, at least I have understood that this has multiple effects which are yet to be explored. So this is what I learned. I mean, I'm just trying to make it simple that this angiotensin 2, please don't mistaken it with the enalapril and all that. They have different action. AC2 was a specific target. It is a different enzyme and it has the multiple roles in the lungs. Now we discovered. So, having understood this, I'm talking of this 2020 itself. Now, after 2 years, I mean, this figure I got from after 2021, that somebody wrote that, okay, ACE2 has multiple effects ranging from CNS or eyes or heart, vasculature, liver. Now just, and one more which is not added here and which I learned from Dr. Mogana, the female reproductive organs, specific damage which might be occurring. See, what I am trying to say, that multiple actions which were seen in COVID, you can visualize from this role of this, and this is the target for that virus. Well, we tried to understand it more, and based on that, I was actually asked to write a review article that what could be the targets in the COVID. And based on that simple molecular studies, we could find that AC2, we were targeting only this enzyme and multiple sources of various compounds. We could find that yes, it had some of the compounds had those hits which I am talking had. I mean, some of those hits like routine, some of the compounds from the two plants, I can name them, Califa indica and the Solanum nigrum, and others they were there, but we could find that. See, remdesivir and all, they had the effect on the RDRF. The compounds from the herbals also could have that effect. But based on this approach, so we had the molecular docking approach, then we could find that, okay, these plants have those very high activity with the enzymes. So that we selected, and with the help of that, we made a formulation. To our surprise, that had a beautiful dose response inhibition of the viral entry itself. And it was done in one of the university in USA, and we could find the clear-cut results. And then, even in the hamster we found the same. This was our drug. We continued that. Even the patient studies, we had 144 patients who were treated with two. I mean, it was a parallel design clinical trial, and we could find a green means cure. So within 14 days, every patient was cured if it is given the medicine. But no others, when they were given, some of the patients could not be cured. Well, we did all sorts of studies as per the clinical trial requirement, the score of the prognosis, the biomarkers also we had, and we could see that there is a clear, significant difference, and results were there. Even the IL-6, the biomarker, was found to be reduced significantly, not others. But yes, what I'm trying to conclude now here, that the approach of biomarker. So to me, biomarker AC2, biomarker associated cytokines, and based on docking or other studies, we could find that our phytoconstituents, based on the traditional medicine, the plant material, if you can see, we can come to a good herbal formulation which can be tried to the cell-based studies and go for the clinical trial. A faster success will be there. It took about 1.5 years. It could be used. I mean, within 1 year, we could start giving it to the patient, because we could try that. This was a very pathetic condition. Pandemic was there, and with limited trial, we could do that. So we could succeed that. So what conclusion to me for today's meeting is that yes, as a pharmacist, we are looking at the non-adherence to efficacy and all that. But the other side of our pharmacy, new drug discovery, we can definitely play important role because the patient interaction, what we learn, it becomes more and more important. And it could be a translational study because biomarker based translation. So I tried to explain on the basis of understanding the disease based on the biomarkers and then go for it. That's what I've tried to show the example. I'm thankful to my all colleagues who were associated because it was a marathon task to discover something in this. So thank you very much and thanks for inviting and giving me the chance. Thank you very much. So I believe in a different way, like not what others say and we just copy. Yes, be in a different way. Thank you once again, Dr. Erwin, and the organizers for giving me this. Thanks to Mogana and Dr. Virano. Thank you.
Okay. So thank you, Professor, for your nice presentations. And for the audience, anyone, would you please raise your hand if you want to ask a question? Anyone? Maybe from our online participants? Ya. Ya, silakan. So we have one who want to ask questions. Amik. Cek, cek. Cek, cek.
Good morning, Professor. I'm Dr. Mintoro
Good morning.
Sumegro from Indonesia. I'm the director of the Polytechnic Kesehatan Air Force in Yogyakarta. I want to talk about pharmacy and economic. Development of pharmacy is depend of development of medical technology. I want to talk and share experience from Professor. In the pharmaceutical, the price of pharmaceutical product from India is cheaper than another country. How could this happen? The product pharmacy is depend from the evidence-based production and promotion. I want to share experience from Professor. Thank you very much.
Okay.
Jadi kalau
Thank
terjemahannya.
you. Okay. See, drugs are cheaper. Just, question is, drugs are cheaper partly if you have the proper quality standards are to be there with all that. And that is what is actually maintained. Now in India it is cheaper partly maybe because of labor, the cost cutting, and see the discovery, new drug discovery sometimes takes more time. Now I remember in 1972, there was or something like a process patent was there. So if a chemist can synthesize the drug with a cheaper route or using the green chemistry, something you can save the cost. Now same thing is happening here also. on one side, the drug discovery, when we say, you need more and more sophisticated equipment, and they become obsolete. The cost goes up. But now, the way in which I have presented one, that okay, you have a different approach to discover a new drug. You will have a cheaper options. So what I'm trying to say in nutshell, it is the approach how we have. Approach without compromising the quality. So it is cheaper. It doesn't mean that there is any compromise in the quality. No, it is not there. Only thing is that yes, we try to have the strategies are different and partly a little cheaper when it comes to the cost of manufacturing, the labor, all these factors are there. So that's what I can say. I hope I could answer that.
So how is it answered? Yeah, okay. So is there anyone who wants to ask questions? Maybe one's in the back. Okay, so I actually have one questions, if you may, Professor Ramesh.
Yes.
Okay, so it is about the reverse pharmacology, and you stated at your slide that the first step of the reverse pharmacology is a large-scale trials, and then we move to the relevant science and the safety at the next step. So,
Yes.
check. So, is it okay?
I will tell you, I understood your question. That see, the one thing is that like traditional medicines, they were considered as safe. Now, it was based on somebody tells, maybe a rural area, in a village, somebody says, okay, it is effective, and we believe it. Or you can say there are texts written. We have Ayurveda texts, Chinese texts, or anything like that, or Unani. Now, what is written, we have to authenticate. So that's what we feel that it can be a limited trial, clinical trial, because otherwise also patients are using it. But using the proper markers can be established. Like somebody says this is an anti-diabetic drug. Okay, he says based on the symptoms, okay, if somebody says that yeah, patient feel better if you give to diabetic. But as a modern science person, I will say no. I will like to see before drug what was the glucose level and what was afterwards. What were the lipid parameters and afterwards. So this is what it means that large scale, the clinical trials can be done, and then based on that have more toxicity studies done, more mechanistical, and you can find better. Like starting with simple salicylate, now we have so many analgesics. Starting with that Rolfia serpentina, antihypertensive. Now you know the mechanism, it is sympathetic system, and a large number of drug could be discovered. Same thing is happening with amnia. So like that, you have to authenticate and then move further. That is what is the real reverse translation.
So it is not only based on empiric. Check.
Hello? Yes.
So it is not only based on the empirical
Sorry?
evidence, right?
Yeah, no, it is based on empirical,
But not
but
only.
empirical also has to be document, it has to be
Okay.
re-justified. You have to confirm it.
So we started from the empirical evidence,
Yeah.
then we move forward. Okay, so from participant. Any one of you? So, Professor, I think we have very nice seasons in this after. Check. Satu. Okay. So I think this is the end of these sessions, and thanks again, Professor Ramesh, for your nice talk and discussions, and give a big applause for Professor Ramesh. Thank you. So.
Thanks. Yeah.
Cek satu. So this is also at the end of these sessions, and thanks for your attentions and for your enthusiasms to follow up this session until this time. So I'm back to Miss Erna.
Okay, thank you for Mr. Aji and dear all two participants. This is the last of the first session, and we have the second session at 1 p.m. Okay, this is the end of the first session. You can isoma or rest, pray, and have meal. Thank you, and assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you. Bapak Ibu, mungkin bisa dilanjutkan ke kegiatan isoma, lalu kita lanjut di pukul 1 siang ya Bapak Ibu di ruangan ini. Terima kasih.
Oh yeah.
Recording stopped. Good morning, Prof. Mogana and Prof. Hirano.
Recording in progress. Recording stopped.
Oke, selamat siang Bapak Ibu. Mungkin acara akan kami lanjutkan ke sesi 2 International Conference-nya ya. Oke. Oke, Assalamualaikum warahmatullahi wabarakatuh. And good afternoon to all of you. And now we have come to the second sessions. And in this sessions, we will have two keynote speakers. Professor Dr. Viranutnisa Parton from World Union for Herbal Drug Discovery from Wailala University, Thailand, and Association Professor Dr. Mogana Sundari Rajagopal from Faculty of Pharmacy,
Recording in progress.
UCSI, Malaysia. And we also have two sessions, and the first session, or our first keynote speaker for this session is Association Professor Dr. Mogana Sundari Rajagopal from Faculty of Pharmacy, UCSI, Malaysia. Good morning, Prof. Mogana.
Good morning. Thank you very much.
Yeah. Can you hear me clearly, Prof?
Yes, I can hear you clearly. Thank you.
Okay, Prof. I will read about the biography of Professor Dr. Mogana. Okay, Professor Dr. Mogana was graduated as a PhD from University of Nottingham and as a pharmacist with more than 21 years of practice experience, currently an academic pharmacist, and she would like to bring the influence of academic network to the society and use her expertise to inspire and empower the next generation of pharmacists in workforce development and to guide impactful research and publication related to the advancement of the practice and science. And her practice and academic experience allow the development of innovative community engagement to meet the present and future needs of community aligned to the vision of mission of MPS. Okay, I think that's all of the amazing biography of Professor Dr. Mogana. And now the time is Prof. Mogana, and Prof. Mogana will explain about her presentation. Okay, Prof, this time is yours. Thank you.
Thank you. You'll be sharing the slides?
Okay, Prof. Please wait a moment.
All right. Very good afternoon to everyone. Thank you to our beautiful MC. Selamat sore to semua ibu dan bapa. All right, so I will try to do this presentation in English, and hopefully I'm able to mix some bahasa in it as well. So today, as what our beautiful MC has mentioned, I'll be talking about antimicrobial resistance, or what we commonly know as AMR, and how this can be potentially overcome considering the biodiversity and therapeutic potential of Asian medicinal plants. So before we begin, next slide, I'd like to share a little bit on, next slide please, a little bit of where I come from. So in the morning, I think we have witnessed MOU signing between our Indonesian counterparts and UCSI University. So this is our campus. We have a couple of campuses throughout Malaysia, from Kuching, Sarawak to Peninsula Malaysia, Kuala Lumpur, and to Spring Hill, Port Dickson. So next slide. So this is our hospital, which was launched last year, a 1,000-bedded hospital with the latest operative theatre and technology. We hope that in the future, really welcome all of you all to come and pay us a visit to our campus as well as our hospital. Next slide. So now introducing, this is our faculty team. We've just recently had our convocation just a few days ago. And there we have our team, a mixture of people from all over the world. We have people from the Middle East, we have from India, we have local Malaysians, we have from Ghana, Nigeria. So the complete mixture of academic staff from all over the world gives our student the good pool of skills and knowledge, especially when it comes to pharmacy practice. Next slide. This is our conference that we held just before the COVID pandemic hit us in March 2020. So this is our whole team. So I'll also be sharing on our upcoming conference next year in March. So hope all of you all can join us. We really will be obliged to have all of you on board. Okay, so moving on to our topic today. Next slide, please. Okay, now when we talk about antimicrobial resistance, okay, now looking at the forecast, at the rate that antimicrobial resistance is happening in the world right now, all over the world, now it is forecasted that by 2050, more than 10 million people will be dead, with an over 100 trillion USD loss. Now, this is an alarming pace, definitely. It is very, very alarming, because when we look at all the causes of death in other areas, tetanus, even road accidents, cancer, doesn't even come close to antimicrobial resistance. So, although it doesn't seem like it is a very serious case at the moment, but when we look at the statistics, definitely is very, very alarming. Next slide. So what is, when we look at this all over the world, if we look at the statistics, we can see the mortality rate is very, very high, especially in Asia region. We can see that. That includes Malaysia, Indonesia, China, India. It's very, very alarming. Next slide. Now, antimicrobial resistance, what is it? So when we look at it, it's actually a natural process, whereby when the microbes, microorganisms evolve, they are able to resist the action of a particular drug. So this makes the drugs ineffective. Now, how does this happen? So a very simple way of putting it, step one, if you introduce, you have in a population of bacteria, you have different kinds of bacteria, and one bacteria can mutate and become antibiotic resistant. So what happens is the antibiotic kills all the other bacteria, step two, except for that one resistant bacteria. So how does that bacteria becomes resistant? Due to genetic changes, mutations that occur in the cell during replication. So what happens is all the other bacteria are killed except the resistant one. The resistant one then goes to and multiplies, forming a population of antibiotic resistant bacteria, as we can see in step 3. And step 4, what happens? This particular population of bacteria then moves on, transfers their genetic mutation to other bacteria, deeming all the other bacteria to be resistant to that particular drug as well. So this is how commonly antimicrobial resistance happens. Next slide. Next slide, please. So all over the world, we can see currently, as most of us here are pharmacists, I believe, and we have seen that many things have been done in all over the world to actually look at increasing antimicrobial stewardship, we call it, whereby we have certain guidelines, antimicrobial prescribing policies, and also many things. So overuse of antibiotics is definitely a cause. Overuse in hospitals, patients who do not finish their treatment, exposing themselves to resistance. Also in agriculture, when we look at overuse of antibiotic in livestock, fish farming, antibiotics flowing onto the water supply, and poor infection control in the hospital. And most importantly, what we can see is lack of new antibiotics being developed. So this is going to be one of the things that we're going to talk about. Next slide. Now, if antimicrobial resistance is a naturally occurring process, so why is there a threat? So we can see that microbes will be exposed to larger amount of antibiotics, correct? So this increases their chance of developing resistance, as we have seen just now. Now, however, there are very limited numbers of antibiotics, right? And have there been new drugs being developed to kill these bacteria? We have not had. So how long has it been since we had a new antibiotic? So the demand for new drugs have increased because resistance rate is increasing, but new drugs are not there. So this has led us to have a dried up situation, leaving it in a very dangerous situation where it has become a threat. Next slide. So if we look at the timeline of how long has it been since the time that mankind discovered the first antibiotic that we commonly known, penicillin, 1928. So from there, what has become the journey of mankind in this? So if we can see, for the past more than 30 years, we've not had any new antibiotics. It has basically stopped somewhere in 1995, right? So if we look as of recent in 2017, there was actually tazobactam that came about, a new class of antibiotic that works in an innovative manner. And if we look at the latest WHO analysis in the year 2020 on how many new antibiotic or candidates or new chemical entities is in clinical development, so we can see that they have over 43 antibiotic combinations and on. But out of this, only 26 antibiotics are addressing the priority pathogens, those that really have severe resistance in treatment. So from these 26 antibiotics, from there's only 7 who meet the WHO criteria. So what is WHO innovation criteria? So they would need it to have absence of known cross resistance. They would also need to have a new target or receptor target, new mode of action, and a new class. So out of these, only 7, out of 26, only 7 meet this criteria. And out of these 7, only 2 are active against MDR or multi-drug resistant bacteria. So this again leads us to a situation where we don't have enough. So this is very chronic. If we have a look at the WHO website, on all their writings, we can see this is a very chronic situation. Now, so the problem with development of new antibiotic is the lack of new scaffolds. So we have situations where synthetically drugs from the existing antibiotic chemical structure, there is some changes in the structure synthetically, and they are investigating those kinds. We also have types where they're taking current antibiotics and combining it with certain molecules, what we'll discuss later, that is known as bioenhancers. And then we also have some existing antibiotic that is being converted synthetically. However, all of this revolves around the original chemical compound, which the bacteria have become resistant. So some changes here and there. But when we look at what WHO wants, new compound, because we need new scaffold, we need new chemical structures that the bacteria have never come across. And this is how we're going to enhance the killing effect. So next slide. So when we look at the kind of, when we talk about MDR, MDR is one way, one of the system that bacteria become resistant. But there are definitely others that have come about. Now, MDR is basically, as we all know as pharmacists, whereby the bacteria are non-susceptible to at least one antibiotic in 3 or more antibiotic classes. So we have nearly 7 to 8 classes, from penicillin, cephalosporin, tetracycline, and so on. So then in recent years, we also have seen XDR, or extensively drug resistant, whereby the bacteria are non-susceptible to at least one agent in 2 or fewer classes of antibiotics. And then we have the latest one, which is pan-drug resistant, whereby the bacteria is resistant to all agents in all the classes of antibiotics. So it has become more and more serious. And in 2016 and 2018, if we have seen, we also have something you call usual drug resistance, and a new classification called difficult to treat resistance, whereby they look at the efficacy and the toxicity of the antibiotics. So next slide. Next slide, please. Okay, so now what is post-antibiotic era? So if you look at all this resistance that is happening right now, there is a full stop where most of the clinicians, pharmacists, we can't do much because there's very little to work with. There are only the established classes of antibiotic. Nothing has been discovered, nothing novel has been discovered for the past 30 years. And why is this? Are we in such situation? Many reasons. Economic reasons. Pharma industry do not want to invest the money, because once a new antibiotic is there, the bacteria have gained some kind of resistance and they feel that they're not going to make money anymore. So all this, a lot of implication, politics, economics, and many reasons for this. So when we talk about post-era, we talk about the era where bacteria are resistant to antibiotic. That's what we are looking at right now. And then obviously many countries, including Indonesia, Malaysia, we have tackled this in many ways, where in Malaysia we have Malaysian National Antibiotic Guidelines that guides the prescribers on the way to do it, to ensure less resistance happens. And then we have the national state campaigns to contain antimicrobial resistance. And of course, we have antimicrobial stewardship program that sees active participation of pharmacists in all the public and private hospitals in the country. So I'm very sure that Indonesia has a very similar system. However, at the end of the journey, there's always the question, where is the new scaffold? Scaffold meaning the new structure to whereby that will, at least for example, from penicillin up to today, we've seen from 1928 up to today, 2022, it's been many years, all right, that penicillin took, where bacteria took to actually become resistant to penicillin, because it's a new scaffold at that time. So if we do have a new scaffold at this time, again, it might take, we can be a little bit comfortable for a couple of years before things start happening, and we have to continue the search for new scaffolds. So how do we do about this when synthetically scientists have come to an end? So, or at end of the road. So we have to go back to what we look at, where can we find new scaffold? And this goes back, this takes us back to nature. So moving on to next slide. So if we look at around the world, now we have a couple of countries, roughly around 12 or more, where they have been identified as having mega diverse or high biodiversity. And this includes definitely both of our countries, Malaysia and Indonesia. So what does this biodiversity rich country mean? That they are very they have high levels of endemism. That means local plants specific to that region, and the species are very diverse. All right, and this diversity can range from animals to marine to plants. So we can see that especially in the Asian region, nearly every country has very high biodiversity. Next slide. Now, if we look at, let's look at Indonesia, right? Now, if we look at the top, let's say, top 2 biodiverse countries, Indonesia stands at number 2 in the world, which means that next after Brazil, Indonesia has very high level of biodiversity from birds, amphibia, fish, mammal, reptile to plants. So now the next question we need to ask ourselves, have we actually tapped into this biodiversity? Have we actually tapped into this range of treasure that is stored there? Next slide. Now here, this is a very beautiful picture that we can see here. Now this is none other than the Borneo lowland that consists of a forest that is being shared by 3 countries, Indonesia, Malaysia, and Brunei. So now this particular rainforest is the second oldest rainforest in the world that is 140 million years old. Now just imagine, what does a very ancient rainforest have in store? Many potential for scientific discoveries, but they are still not tapped in. Next slide. Now, when we come to Malaysia, now Malaysia is next to the Borneo lowland, where we are the 3rd oldest rainforest in the world, and it is as old as 130 million years. And basically more than 50% of the peninsula Malaysia is covered by tropical rainforest. And of course, Malaysia is also one of the 12 mega diverse centers in the world. So this is where countries like Malaysia and Indonesia, we are different from other parts of the world where we have these national treasures. The next step is, how do we use this pressure, how do we utilize these precious medicinal plants and natural resources to help the scientific world? Next slide. Now, when we look at what is currently happening between what the scientists are doing all over the world, we're looking at traditional knowledge on preservation on plants, traditional utilization of plants for medicinal purpose. We're looking at variety of this. Now, from these plants, all right, many work have been done, is still being done, whereby isolation of metabolites, because plants have millions of phytochemicals in them. And from this, what we do normally is we isolate the active secondary metabolites. It can range from alkaloids, flavonoids, tannins, whatever they may be, different kind of phytochemicals. And then what we do with those? Now, if those potential, with those metabolites, that chemical, the bioactive compounds, we actually test whether they can interrupt the DNA synthesis of a bacteria, or RNA, and then interrupt the cell building, the membrane function, the structure, the metabolism, and all of that. Or we can also look at using the particular structure of a bioactive compound in using what we call docking, in bioinformatics, to look at whether we can change the structure to have better fitting to a particular receptor target of a bacteria, looking for inspiration of new synthetic drugs. Or we can use that and add on, change some functional group. We can do all of this. Or if they are completely novel, a compound that never has been found before, completely novel, this is the beginning of what we call developing a new antimicrobial drugs. So this is where we start to look at how do we use this new compound to address multi-drug resistance? How do we use this new compound to increase efficacy of treatment? How do we increase it to improve treatment choices for the patient? Right? And how do we do this? We can use multiple databases, especially now with technology and artificial intelligence coming about. We have tons of phytochemical screening databases. We have tons of chemical structures of natural product. We have tons of drug targets identified that we can check on signaling pathways. And all of this can be done. So this is usually the process of what we do. Now, one of the common things that is caught up lately is what we call bioenhancers. Now, if let's say the potential of discovering a new compound is very difficult, there's also an option of looking at combining traditional and modern medicine. We call it the development of bioenhancers. So what does this mean? It means that we are looking at a particular antibiotic and we're looking at a particular phytochemical from plants. We're mixing it together and we're looking at whether this combination, it could be 1:1 or 1:2 or whichever ratio it is, whether this combination is going to give a higher kill of the bacteria. So why is this also a preferred way of research? Because of course, treatment cost is lesser in this way, because instead of using more antibiotics, we're going to use less with a combination of a phytochemical. And then there's also the unmet need for new and effective treatment options. If an antibiotic alone is resistant to the bacteria, we're combining it with a phytochemical, suddenly we see that the bacteria is actually being killed. So there is some kind of synergism that is happening between them. All right, and this synergism is what we are looking at to improve the killing rate of this bacteria. So of course, this combination therapy, we can expand the antimicrobial spectrum. All right, we can prevent emergence of multiple drug-resistant mutants, and then we can also minimize the toxicity level because we will definitely use less antibiotics to begin with. So next slide. So now, one of the ways that we can actually do this, and is being done, is the flow chart of how, when we work with natural products, starting from ethnopharmacology, that means the traditional uses of some plants. Of course, we can basically sample any plants in the rainforest, but it's not a time effective and it wastes a lot of resources. Rather, we go back to our roots and look at what our ancestors have been using it. Some of these usages have been documented, some have not been documented. It's usually just implemented within a particular village or shaman or something like that. So this is what we call collecting the plant based on ethnopharmacology. So once we see, okay, they're using this usually, let's say, for certain upper respiratory infection. So this particular group of people, they're using this particular plant for that infection. So what we do then, we then do our screening, our normal in vitro screening, antibacterial screening on looking at what is the minimum inhibitory concentration or bactericidal concentration that is required to kill a particular bacteria. And if it does, we do see it working. Then we move on in isolating the active compound that is responsible for this particular activity. And this is where we do isolation. And if we have discovered this compound, then we see that if it is novel, good. If it is not novel, can we actually combine it with an existing antibiotic to see whether it has synergistic activity, or what we call as bioenhancers. And then if it does, then we move on to mechanistic study. How does it actually kill the bacteria? And then if we have understood the way it kills a particular bacteria, then we look at the in vivo. If we are going to introduce that particular compound in humans, obviously we need to go through animal study, we need to look at toxicity, pharmacokinetic study, and moving on to human study, which is clinical. Now, in the middle of all of this, to save time and utilizing artificial intelligence, is where we look at bioinformatics studies, whereby the investigation from isolation of a compound to all the other mechanistic study. Now, there are times when the isolated compounds, we are isolating a lot of compounds, and they may not actually work, and we spend a lot of resources in checking for the mechanistic study, in vivo, in vitro, and all of that. So before we actually do that, once we have the structure, we can look at in silico studies, and recently what is gaining popularity is what we call network pharmacology. Now, generally, I think we all know, you dock a particular chemical using our database softwares, dock a particular molecule into the target, which is the bacterial receptor wall or whatever it may be, and then see whether does it get tagged on, and then that is what we normally do. Now, but moving on to that, expanding to that with artificial intelligence, what we have network pharmacology. So not only we are able to know whether this molecule using AI is able to attach itself to a particular membrane of a bacteria and it causes some killing. When it does the killing, we can actually see whether this compound may have good or positive or negative activity in other areas of the human body. That's what we call network pharmacology. So we investigate how does this compound not only does the killing, but does it affect or give toxicity or other effects to other organs. So this is what we call network pharmacology. By understanding all of this, then we then can confirm it with wet lab, and that's where we go and do our mechanistic study and so on and so forth. Next slide, please. So just to share what we have done from our institution. So we have a network of collaboration between UCSI University, Nottingham University, and University Kebangsaan, National University of Malaysia, and also University Malaya. So we have this particular team of people where we have a network whereby we have an ethnopharmacologist, and we have a group of people who are doing all of those investigations that we have seen in the previous slide, all tapping on to the natural resources of Asian medicinal plants. Next slide, please. So at the moment, we have investigated over 54 species of medicinal plants from Asian rainforests, from Bangladesh, from Malaysia, Indonesia, East Malaysia, as well as some from China. And some of the results that we have obtained is pretty impressive and promising. Next slide, please. So, and we have also introduced this compounds and some formulations into against 15 of clinical strains that are actually, all of them are MDR strains. So we are focusing on multi-drug resistant strain because that is the current alarming threat at the moment. So, and of course, as a result of that, next slide, we have seen many good activity. Next slide. And of course, at the end of it, we have come across isolation of some compounds from various compounds, and some of these compounds are even being investigated as bioenhancers. Those non-novel compounds are being investigated and combined with existing antibiotics for synergistic activity. So some of the combination can include one bioactive compound to one antibiotic, or one bioactive compound to 2 or 3 antibiotics, especially when we have serious illnesses that require a spectrum of antibiotic treatment, and they're all resistant. So what happens when we combine that bioactive molecule into that spectrum of treatment, then we suddenly see a very high rate of killing effect because they are working synergistically together. Next slide. So what have we learned from all of this? So now we know that although modern cultures and scientific advances spread amongst us all over with IR 4.0 and all of that, at the end of the day, there are certain knowledge back to nature that may not be realized. So this is where we need to go back to our roots. We need to go back to nature, all right? And this knowledge needs to be documented, all right? And because at the end of the day, what we see in nature, all right, we have to also be responsible, whereby this is where sustainability, environmental sustainability is very, very important. If we go on with developments, we go on destroying our rainforests, that is also rampantly happening, especially in the Asian regions. What we see is there is definitely a very high potential that all of the untapped treasures are going to be lost to us forever. So this is where, in terms of political, governmental policies, all needs to come together. Stakeholders need to come together and have a system whereby sustainability of environment, of nature is very, very important. And at the same time, scientists utilizing these resources must also be responsible and committed, right? So what we need to look at is, at the end of the day, that the traditional use of certain plants will assist us as pharmacists in assisting primary care, healthcare, all right? Because these are potentially new scaffold for new antibiotics, right? So with this, it is definitely our inspiration and aspiration that as technology brings us forward, we need to utilize this technology and look back at what we have that has not been used. Because no matter how much the synthetic world brings us, we are at a dead end because we do not have any new molecules. And that's what we need at this moment to attend to the threatening antimicrobial resistance. So next slide, please. So thank you very much, everyone. Before we open for Q&A, I would love to see all of you at our conference next year, March 2023. So the scanner code for registration, kindly please visit our website. It's there on the slide. You can actually scan it and then pay us a visit at the website and see. We hope to see you all next year. Thank you very much to our MC. And thank you for inviting me over. Thank you.
Okay, Prof. Mogana, that was an amazing presentation. And now we have come to sharing session, yeah, or Q&A session. And we have 5 minutes to discuss all about this. And all of the participants in offline or online, maybe you can ask a question to Prof. Mogana. Please raise your hand, or you can chat in this Zoom chat. Anyone question? Okay, Prof. I will ask you about something, Prof. Your topic is antimicrobial resistance, biodiversity, and therapeutic potential of Asian medicinal plants, right?
Yes.
Yeah. Okay. Talk about antibiotic, Prof. In Indonesia, we have some cases such as shrimp farmers often use chloramphenicol, one of antibiotics, to make their shrimp grow up quickly. And how do you think about that? And does it also affect our body to be resistant to antibiotics? Thanks, Prof.
Thank you, Ms. Erda. So definitely, if we look at shrimp farmers, or we look at basically, we say farming, whether it is marine or livestock, all right? So this is not something new. It's been happening for many, many years. We have seen how chickens are being fattened up by using antibiotics as well. All right, and of course now in marine livestock, marine farming as well. So obviously, as pharmacists, we all know that this is not good. Why it's not good? For example, if we take the antibiotics that's being given to the chickens to fatten them up, there has been cases, documented cases of it being overflow, all right, into people when we consume it, into the meat. And of course, this also gives other complication where it increases estrogen levels in people who consume it. and increasing estrogen level in men, increasing estrogen level in women, and of course, when the hormonal imbalance is off, many implications starts happening in the human body. So this is definitely not. So that is why at the end of the day, there has to be government policies in place to prevent this kind of usage. So because the victims are the consumers, and these are humans, people like us. So antibiotics, and this is also one of the ways that resistance increases, because it is being used not in a way that it should be. It should only be used for treatment, but it's not. It's being used for some other unethical purposes, which should not be condoned, right? So definitely when we look at pharmacists' role, just to add on Ms. Erna's question, antimicrobial stewardship campaign is very important. We really need to put our feet up there, emphasize the role on how we can influence prescribers, influence healthcare and stakeholders on ways to practice dispensing properly, prescribing properly. How do we get patients to finish their treatment? Because if they do not finish, that also gives risk to antimicrobial resistance. How do we improve infection control in hospital and clinics? Because that is one of the main site where resistance happens. And how do we improve hygiene and sanitation in public facilities? So all of this is it's areas that really need a lot of input from every healthcare practitioner, especially the pharmacist. Thank you, Ms. Erna.
Okay. Thank you for your nice explanation, Prof. Mogana. And because the time is end, we can give applause to Prof. Mogana. Okay, thank you, Prof. Mogana, for your amazing sharing session today. And now we have come to the second session with Professor Dr. Viranut Nisaparton from Thailand. Okay, good morning, Prof. Viranut. Can you hear me, Prof?
Oh yeah, I can hear you. I can hear you.
Okay. I will read about the biography of Professor Dr. Viranut Nisaparton. Professor Dr. Viranut Nisaparton is from World Union for Herbal Drug Discovery from Wailala University, Thailand. And Dr. Viranut graduated as a medical doctor from Lady Hardinge Medical College, University of Delhi, India, and Master of Clinical Tropical Medicine from Mahidol University, Thailand. And she was working as a contract lecturer and later as an associate professor at the Department of Parasitology, Faculty of Medicine, University of Malaya, Malaysia for almost 2 decades, from 1999 until 2017. And she is currently working as an associate professor at the School of Allied Health Science, Wailala University, Thailand. And Dr. Viranut is actively involved in her research area of some interest. At the first is infectious parasitic disease, include epidemiology and clinical relevance. And the second is diagnostics challenge. And the third is natural product. And then water-based research. And the last is health awareness on both anthropologic and zoonotic aspect. And Dr. Viranut is a coordinator of an international research network, Southeast Asia Water Team, and World Union for Herbal Drug Discovery. And she has published more than 150 papers, including book chapters, and is an editorial board member of reputable journal, as well as an active reviewer of more than 60 international reputable journals. And She also served as the editor, then a speaker, then adjunct faculty, as well as visiting professor. And Dr. Viranut is the recipient of an outstanding Dr. Matthew from USA, and she is also a recipient of the Outstanding Scientist Award at the 9th International Scientist Award on Engineering, Science, and Medicine in India 2020. And recently, Dr. Viranut has been listed among the world top 2% scientists in general and internal medicine based on career-long data and single recent year impact categories by Stanford University, USA, 2021. Okay, that was, I think that was an amazing biography, Prof. Okay, now we have come to presentation. Now you can explain about your research, Prof. Okay, this time is your, Prof.
Okay, thank you very much for your kind introduction, Erna. And I'm very happy actually to be here, okay? And then, share some of my work, okay, with all of you. Particularly, I still don't have any Indonesian, collaborators so far, okay, in ASEAN particularly. And I also thank you to Prof. Mokana, yeah, for recommendation, okay, for Prof. Ramesh and me, okay, to be one of the speaker here at your conference. It's a role, actually my topic is very relevant to pharmacology. When you talk about the plants, you talk about medicines, yeah. Even though I'm professionally, I'm a medical doctor that I usually get used to with on the modern medicines, but now I'm so very interested, okay, focus in the medicinal plants. So what happened with the role of Asian native plants against Acanthamoeba infections? I think this will be very much of the future prospects. Yeah. Okay, then. Okay, so thank you. Thank you for the invitations and organizers of the 4th International Conference on Pharmaceutical Research and Practice 2022. I think when you talk about any topics, particularly that now I'm going to talk about Acanthamoeba, definitely you have so many questions coming to your mind. Either what is that, where you can get it, or when, or why, or how, and who will be, affected of these, problems. Yeah. Okay, and then I would like to share about 4 areas of my talk. One is about medical importance. Second is about medicinal plants and advanced technologies involved in my work particularly. And One Health, what is a global consensus? And lastly, I also would like to touch on about the International Research Network. Okay. Okay, so what is Acanthamoeba? Acanthamoeba is about the environment, talk about the waters, yeah, talk about the human health, okay? And this is Acanthamoeba you can see anywhere, okay? You can see anywhere in the world, and particularly in the water, contaminated water sources in the environments that you can see, yeah. Acanthamoeba actually you have both, no harm, non-harm, and then it's a harmful, okay, parasites. And what the parasites that I'm looking at is about the harmful, okay, to human bodies, yeah. So we call it as a pathogenic Acanthamoeba, and particularly in the group 2, you can see that it's Acanthamoeba triangularis. Even though Acanthamoeba castellani is the most important, yeah, or the most common, okay, clinical features that you can diagnose in any patients, yeah. But fortunately, that's the Acanthamoeba triangularis also come into this group, yeah. And then you can see that Acanthamoeba keratitis, okay, that's one of the problems, okay, in the eye of the people that, infected with these parasites. Is about emerging disease gathering important worldwide. So you can see that this is how you can get Acanthamoeba, okay, either from the waters, from through the nasal passage, to the, lower respiratory tract, yeah, or otherwise you can move to the brain, okay, or can be on the skin. So usually it can be localized, okay, in any area in the body, or otherwise they can be disseminated, okay, in any parts of the body as well, okay. So you can see that what happened in Acanthamoeba keratitis, particularly in Asia, that, we are living with actually. So you can see quite a number of, countries that have been reported, okay, particularly in South Asia, that including, specifically about the Pakistan, Okay, you can see so many people from Pakistan, waterborne parasites, on to sister, brother and sister, just like Acanthamiba and Nigri. Okay, and then we can see from other country as well. Okay, just like India or whatever. I think when I first joined, okay, at Walalak University, I also carry this parasite along. Okay, I'm so thinking because when I was in University of Malaya in Malaysia, we are also working on this already in a waterborne parasite, not just only Acanthamiba nigeria or Cryptosporidium giardia, okay, but this is the one that I still continue the work, okay, at the Walalak University, and then we also try to see what happening, so, just before we started our job, so we see what happening just like a review work, okay, throughout ASEAN, okay, as our neighbors, okay, neighboring countries like that, so we can see that Acanthamiba so have been reported, okay. The maximum I think I can see is from our friends, okay, our colleague, okay, in Malaysia. Yeah, I think they have both, in the lab work and in the clinical study as well. Yeah, so this is the part that we have review, okay, throughout the ASEAN members. So what happened with Acanthamiba? How you going to get it? Yeah, I think risk factor they are quite very specific risk factors. Just like you use contact lens, yeah, that's why they can go to the eyes, okay. Or otherwise you just like you swim in the water that you don't know that Acanthamiba are living there as well. Because most of the time people like to think about bacteria. They think about virus, but it's quite common, and also it's very dominant of microorganisms compared to Acanthamidas. Yeah, but however, you can see that Acanthamiba also can move around everywhere. They can. That's why they call them as a free living amoeba. Even they can live anywhere nicely, happily. Okay, and that's it depend on the environment that they can adapt it with. Yeah. Okay, so you can see that actually Acanthamiba there are two forms. Yeah, one is a trophozoite. The second one is the seed form. Trophozoite actually is quite simple. They have only one layer, okay, of the worm, so it's quite easy, particularly when you use the drug. Okay, that I'm going to talk to you later. And then about the seed form, that they are double layer, okay, of the worm. So that is very difficult to penetrate. That is how we know that seed form actually they have the tendency of resistance. Okay, resistant to the drug, and usually on the modern drug that's exists or even available in the market, actually they are target for the trophozoite, yeah, not the seed form. Okay, so now our work really focus on the seeds. Okay, so you can see that not just only the Acanthamiba that can cause eye problems, okay, but also they can go to the brain. May not be exactly just like fatal disease, but it's a life-threatening disease. Okay, when compared to the what's called Neisseria fowleri, that is totally fatal. But this one life-threatening if you really can diagnose and then treatment in time or beforehand. Yeah. So you can see that there are a number of the country around the world that have been reported of these problems. Yeah. Okay, of these problems. Yeah. So you can see that here in Asia, in Taiwan, in Thailand, okay, in Japan and China. Okay, so this that have been reported of the cases of these granulomatous amoebic encephalitis. Yeah. Okay, so this I just want to show you a little bit of how differences between Acanthamiba with other free living amoebas. Okay, you can see that less or more they are quite a bit similar. Okay, but not totally the same. So that's why that we have to really be careful and be perplexed that okay, on this can be happen without your own alarming. So that is have to be careful. Okay, so this is the one. And then how the when you talk about humans, yeah, that's why I'm focused about the One Health approach that when we stay in the environment, we have to be healthy in the environments, in humans, and also in the animals. Yeah, I'm an animal lover actually. So you am quite focused in the animal, but this also is quite interesting that they have been reported that Acanthamiba choroiditis have been reported, okay, in animal, in the canine, okay, in the dogs, the cats, okay, or even in the wild birds, okay, that have been reported. Okay, so you can see that they are the link, okay, between humans, animal, and environment. So we have to be balanced or optimize it, okay, to the best that what we can, and that's how the benefit also can go back to respective, okay, parties. So this Acanthamiba choroiditis that won't quit. I love this article actually wrote by ophthalmologists, okay, in America, that they talks about it, particularly it aren't over till it's over, definitely. okay, because this thing is going on, and the best that you can do is about prevention. Actually, it's quite simple. Okay, it's suppose you look after, you clean, you know, your contact lens very well. Okay, you look after yourself when you go to the, you know, swimming, so to ponds, so whatever. So this how is quite simple. Okay, simple prevention actually. Now we come to the point that I think pharmacy will be very interesting. That's about the plants. Why so important actually on the plants, and why I'm really interested in this topic particularly. I think that the World Health Organization have been really recognized it, okay? Not just only, I think even before COVID-19, and now when become COVID-19, even better, even much more, you know, concentrate about the herbal medicines. I think as Prof. Mogana also mentioned that actually it's quite cheap, okay? It's a cheap, it's a less side effect, even no side effect also. It's available even in your own kitchens, yeah? And this is how I'm going to talk to you regarding to my works, yeah? Okay, so this is how the World Health Organizations have been recognized, provided we have the evidence base to tell them, to tell the world that, okay, it's really work, okay, through the, you know, clinical trial, to the, you know, series of the lab work, so as an evidence base. You can see the plant-based medicine actually is not something new, right? It's not something new. As we also know from China, from India 1,000 years ago that they use it, you know, it's not something new actually, but suddenly become very scientific proof. This is very important. It's just like, you know, household chores, or maybe you use it privately, scientifically prove there are differences, yeah, before you can produce as a proper, you know, drugs or whatever that's available, or treat the humans, that we know that human is the highest, right? It's the highest animal realms, what can I say, okay? So that's why that we have to be careful, yeah. So this also plant-based medicine also really use it, okay? Then also they try in parasites. So now in general objective of my work, actually we investigate, okay, on the selected plants that we have, and then we analyze certain part of the phytochemical, particularly the main compound. If you can see, okay, in international journal, particularly that in on the high impact journal, they really focus on the compound, not extract. Okay, when you send their extract, and then they immediately they reject, okay, because they feel that's still not at the end of the road. Okay, so the best that we try, that's why now we try our work every pieces that we try to get compound at the same time, and then we try to involve with on this advanced technology, just like metabolomic, proteomic, nanotechnologies, yeah, particularly nanotechnology, that I'm going to tell you the reasons why I really focus on this. Okay, so this is the Southeast Asian water team when I was in UN. Okay, suddenly yet, okay, I just think that working just one or two people may not be enough and not very exciting. So that's how I started international, you know, research network with among our ASEAN member. Okay, so we get about 6-7 countries, and then we send our postgraduate students, okay, to get on the correct on the water from the environments, and then come and, you know, test it with our waterborne parasites. Okay, Cryptogyria or even Antimicrobial, etc. Yeah, okay. So this is the area where I corrected our Antimicrobial triangularis, and it's confirmed. Okay, confirmed with the molecular, okay, diagnosis. Yeah. Okay, from Walalak University. So usually what I can say is that this is about environment. Okay, this is about our environment. If you want to have a safe water, either drinking water or is the breathing or so whatever, I think that we have to start from here, okay? Because this is also the area where the people like to move around, okay? And then when we come to the lab, we get on that water, we isolate the parasites, okay, through the in vitro study with the culture. Culture is quite the main aim that we try to get it, okay, and confirm it with the molecular diagnosis, yeah. And then after that, we try with the plants that Prof. Mogana so mentioned it already on the procedure. I think our procedure actually for plant extraction, less or more the same with others, okay. We do the MIC, we do the IIC 50s, we do time cues or whatever. That also we do, okay, we do on this. And then we move to the nanotechnology and the advanced, just like molecular doctrine or dynamic simulations, okay. Whatever is there in the work. I just want to share you some of my work, okay, right now that we keep producing the work, okay, according to the plants, okay, against Antimicrobial. This is come at the first one, okay. We were very happy with the curcuma longa. I think you know, right, turmeric. that usually we are Asians, okay, we use it, okay, in our, kitchens, particularly with the curry. Okay, so this is really work. It's work wonder, you'll be surprised of that. Okay, and then this how we can see the growth, particularly trophozoite. They can really, what they call slow down, okay, or remove the trophozoite state of Acanthamoeba when compared to the cyst. I think, as you know, I think mentioned earlier that the cyst is quite difficult to remove, but however, these two also is work, okay, for curcuma longa. Another one that we do, I think, as we know that Acanthamoeba, there is a feet, okay, that's how they can, attach to the surface, okay, so we call as Acanthapodia, that is a false feet, yeah. So what happens that Acanthamoeba longa proves that, okay, it really can reduce the adhesions of this Acanthamoeba triangularis, and particularly you can see very clear with the SEM, okay, electron microscopy. Now you can see that on my work, last time I'm just doing epidemiology, but when I come further, I think this on the technique is very important, okay? SEM, TEM on this, now we explore on this, aspect, okay, of the laboratory diagnosis. Yeah. So you can see curcuma longa is very good. The curcumin also we use it, okay, and turn out to be is quite good, okay, to remove on this what they call Acanthamoeba triangularis, both the soil and the cyst. Yeah. Okay, and then we can see it's confirmed with the SEM. Another one that is a plant, and so I think, I don't know that it's available not in Indonesia, but it's quite common in the south of Thailand. This about the Garcinia mangostana. Mangosteen is a fruit. Yeah, it's a fruit. We use that the peel, the skin. I think as we like to say, when you talk about the sweet, they're talking about sweet coated peel, right? Sugar coated peel, so that is not good. But you talk about the bitter. Bitter actually is kind of the drug, the medications that they use it. And I think this is approved quite well because the skin of mangosteen is very bitter. It's a thick bitter as well, yeah. So this is the fruits, yeah. Inside is very nice. One is a white fresh, okay, that sweet, so nice, yeah. But the one that we use is about the skins, okay. And it's work wonder, okay. It's work wonder also with the Acanthamoeba, okay, both the trophozoite and the cyst, okay, and you can see that it's really, check off the parasites, okay, through electron microscopy, because every time when we do the wet lab, we also have to do just like I cannot say the dry lab, but it's similar with the dry lab when you do with the microscopy, and then you have to confirm it morphology, that how it changes. So this one totally changes, Yeah, I will show you later. I think this is another plant that we use it, okay? We got it from Cambodia. I think since we have the international language like this, quite good, okay, that we can help out. So this is the plants, okay? Right? This is, the one that I think we have in ASEAN, in Malaysia. I think in Thailand, it's very nice. It's quite juicy, yeah? And this is another one as well, Conbitum and Nona. Okay, so I think among all the 40 plant extract that's sent to us from Cambodia, I think these two turned out to be quite good. Okay, for Acanthamoeba, both trophozoite and the cyst, but trophozoite actually is the better. Okay, it's better. This is another area. If you are interested, you can join us, or you can contact the persons. Yeah, it's from Dr. Ratchasak Bunhok that he's talking about the autophagy. That's about the pathway. That's they have some kind of the of the cytoplasmic that they want to remove on this, just like foreign bodies. Okay, to maintain our homeostasis or whatever. So this is the one that's very good. Okay, we got the plant from Iran. Yeah, Iranians are quite. They have some kind of the limitation, Iranian, because they have some problem with the sanction from America. So usually, they will send the plants to us, and then turn out to be 2 plants that turn out to be very good. Okay, and then using it, and then with selected of the genes that we do it in our works. Yeah. And this is the plant. This is another one. Okay, it's a Paganums. Okay, Hamalan, so extract that we use for particularly for the soil. I think soil is quite easy, particularly in the lab work compared to the seed form. Yeah, in some of the reasons. Yeah, but it's very exciting when you get the answers of that. Okay, so this is how we work in that. Okay, now we come to the Garcinia mangostana as a contact lens. Okay, one thing that is very perplexed and it's very difficult. Okay, because we know that there are people that are contact lens wearer that is suffer for Macentamoeba. But how we going to solve this problem? Because we know that, Garcinia mangostana, the mangosteen, the skin actually is color. So you have to really remove the color. Otherwise, just like the turmeric, it's turmeric the same. Because they have their own color, so they will stain, okay? So this is one of the weak point that we do it, okay, now. But now we also try to do semi-synthetic, okay, of this mangosteen, and it turned out to be also effective, okay, not only for the soil, but also for the seeds as well, okay. So I need we do with the flower, okay, of the mangosteen, and turn out to be it also work well, okay, with the trophozoite and the seeds one as well, okay. I think this is just recently, okay, it's a curcumin effect of this one. A triangularis and C stations under nutrient starvations. I think we know that because of autophagy, we try, okay, to remove on this, okay, with certain of the conditions, and turn out to be that curcumin as a compound, the main compound of curcuma longa, is a work wonder, okay, for these parasites, yeah, okay. Now we come to the 3R. I think that Prof. Mokana mentions about in vivo. I think that as a John Hopkins University, that they have kind of the some kind of interventions or give us the alternative choices, okay, for in vivo experiments. So that's how the thing that I really 100% support for the study of the biomedical sciences, okay. So that's why I always keep it as a 3R, as a replace, reduce, or refine, okay. The most important is about replace. So that's why I really involved with the nanotechnologies, yeah. I try to get the people that they know very well, expert, and then we come and collaborate with that, okay, to avoid this in vivo study, okay. So this is a 3R. Actually, this is a 3R that they use it, okay, and I also 100% support, okay. And this is the first paper, okay, from our PhD students, Dr. Tuba, that's going to join with Dr. Mokana, okay, at the UCSI. So this is the first paper with the gold nano. It's the gold nanotechnology that she did from her PhD. Yeah, and successfully published. She published about 3 or 4, okay, papers, okay, from these Lia indicas. Okay, this is quite common. That's graciously, okay, given by Prof. Christopher Wiers, okay, now in UMS Sabah. This is another plant that I like to share. It's about the Canima retusa. I think it's not common here, even in Thailand. I think they have some kind at the border, okay, between Thailand and Malaysia, and also graciously, okay, given to us by Prof. Christopher. And then it's fantastic. You can't imagine that this plant, actually, this is overview of our work. We already completed. And now we are also writing the manuscript. It's about 99.9 times Q that is really effective against the Acanthamoeba. It's to our surprising and amazing, okay? And you can see that when you go under this microscope, you can see the shape, the size already changed, It's quite different from the control. Yeah, and they are really less or more same, same with the cohexidine that considered as a modern medicine, okay, to treat Acanthamoebas, okay. So you can see that this is how the wonder, this I want to show how the Canima retusa, okay, morphological totally disrupted, okay. It's a collapse, you cannot work, okay, compared to this control. They are so beautiful, right? But when after the cohexidines, okay, even with the Canima retusa, and even in the combination that we do it, okay, for the niosome with the nanotechnology, it's totally gone. Okay, so this is a hope. Okay, it's a hope that natural product really work. It's work wonder and really can replace it to a certain level. I can tell it's to a certain level. For the modern medicine, that is very expensive. It take long and side effect moreover, and it's terrible. Okay, for the people that they suffer from this kind of the infectious diseases. Yeah. Okay, and then this is the one is a synergistic between the two, and turn out to be fantastic. Okay. Fantastic to see that they can work with both the soil and the seeds of the Acanthamoeba. Now, that's what I mentioned to you.
Dr. Viranat,
Yeah.
I'm sorry. The slide didn't change. Still the same.
Oh. From which one?
Objective.
Oh.
Slide.
But otherwise you can use from your slide or not, Erna? Because I think that I already done this part for I shared the slide already,
Oh, okay, okay.
Is suppose like this you can see or not? Can you see this?
Wait. Yes, I can see, Prof.
Yeah.
Still the objective.
Oh, the objective.
Yeah, slide 23.
Oh yeah, but they said that your screen sharing is a power stop. Oh no. Just make it please. Share again. I can share again. Now you can see this.
Yeah, I can see this.
Okay, otherwise I use this one, okay? Is that okay? I use this.
Okay, okay, Prof. I'm sorry, Prof, and you can continue.
I think PDF version is easier then. Oh,
yes.
Okay. This is the one. Okay, this is the one about the niosome. I would like to share about this as electron microscopy. That you can see this on the morphology change, change totally. Okay, compared to the control. Yeah, compared to the control. So this is the one that I think that is really work wonder. Okay, and then this one, so we further for the niosome as a nanotechnology. Now I'm not going to do this kind of the gold nano or silver nano anymore, but I do the niosome because I think the niosome have been proved that it's very good for drug delivery system. Okay, drug delivery system, and then we go through on this process of morphology and histogram for the Candida retusa extract loaded, okay, in the nanoparticles, so become niosome. You can see that after 24 hours of incubation, the amoeba viability reduction, okay, and then you can see just about 0, okay, when it's a loaded, okay, niosome in nanoparticles. So I think that Candida is really work wonder, and I think no one ever done this study before. Okay. Another one that we did for the nanotechnology is about Garcinia mangostana, since it worked well. Okay, so you can see that from here. So combination of these, usually we try to do synergistic because we know that single drug may not be enough anymore, and usually can keep resistance. Yeah. So combination may be another better options. Yeah, better option even though in the natural products. Yeah. So we can see that even combine okay of Garcinia mangostana extract and coaxidine inhibit the growth of the Acanthamoeba triangularis, trophozoite and cysts, okay, at 24 hours, okay, within 1 day, okay, you have some work already. Yeah, you have some work already. So this on the process that we try to come up with the niosomes, okay, nanoparticle. And this is one of the point that I like to share with you, that you see only just a single one, only GME extract. At toxicity of these, Garcinia mangostana started at 62.5. But when the Garcinia mangostana extract loaded niosome, it showed toxicity at 1,000. When it's 1,000, so you see how many times. Then it means that the niosome must be better options now in the future, okay, for us to work more. So I think I still have many plants that I'm really interested, okay, in the nanoparticle. So I think this is one of the exciting news actually, that now we are also preparing for our manuscript. Okay, so you can see that these are trophozoite treated. It's sure trophozoite is quite okay, not too bad. Okay, and you can see on the morphology also it's totally ruptures. Yeah, you can see it gone. Okay, with now from even in coaxidine when you combine it, okay, nanoparticle and coaxidine also is gone. Yeah, compared to the just original morphology of the parasites. So in conclusion is that niosome could be a suitable carrier actually, and for Candida and Garcinia, and I think we have more plans to do it. Yeah? We still have more plans to do it. Another one that now is just going to be accepted in F1000 research. That also we do molecular docking. I think docking now is something that's a dry lab that is can help us to see that whatever we try, okay, in the wet labs, okay, particularly on the phytochemical, and this is how the compound work interaction with the proteins, okay, that we targeted, okay, for particular microorganisms. And this is the one that I think propolis, I think is quite common, right? I think it's the B group. Okay, so this is the one that we successfully also, done our job of this. Yeah, I think MIC also very low. It's very nice. It's very good news actually. And this is how we do the molecular dockings, yeah, and even we do the dynamic simulation as well. Okay, so this is come out very good. is very promising, okay, for the future therapeutic agents. Maybe not exactly the medicine as such, but can be the solutions, yeah, okay, for the contact lens or whatever. So this is how the One Health, okay, I'm talking about One Health approach. We not only do in humans, but we also do in animals, yeah. So certain plants that we choose it, okay, we try for the animal well-beings. I think that in order to this world can move together, okay, we cannot be alone, isn't it? Because our ancestor, ecological ancestor, are from animals, yeah. If they are not here, we also not be here as well, okay. So on this part also, it's our work that we try to balance it, okay, between humans and animals. And this is also quite interesting, okay, it's about coffee. Yeah, I personally also went to this place, okay, it's a coffee plantations, yeah, nearby our university, and we get it, okay, we get on these their fruits, yeah, okay, and then we come and power as an extract, and then we try it, okay. It's not work well for Cantamiba, but work quite well for bacteria, okay. So this is how the One Health umbrella. I think that I also still very concerned about the how to be healthy, okay, both the humans, animal, and also environments, okay. And you see even Academia coratitis, their global support group as well, okay. So you can see anywhere. I just want to touch a little bit for the International Research Network, okay, that I'm a coordinator, okay, for the World Union for Herbal Drug Discovery. If you can recall, Prof. Ramesh, okay, I invited a few of people, okay, last time in 2019, and then since then, okay, about 3 years now we form, okay, and this also name given, graciously given by Prof. Ramesh, and usually we contact through the WhatsApp, okay, WhatsApp chats, right? We don't have any formal, papers or whatever. So this is how our activities, okay, our activities in overseas research activities, yeah. And then we also given on some talk when they invited, just like your conferences, yeah. And on the COVID-19, I just came back from India, and so last month, okay, from Sikkim, and the end of this month, I'm going again to India, to Delhi for another conference, yeah. And this is up call from Philippines, yeah. Okay, so this is on our work, okay, in a collaboration as a co-host, okay, co-host for on the peoples, and we also working as editors, okay, some of us working as editor, reviewers, yeah, and just like a judge, okay, for the university, etc., okay. And so this is something is very, very good. I think it's knowledge is about sharing, okay, it's not about keeping to ourselves, okay. Otherwise, it's not nice. I think I did this animal awareness day 9 times, okay, before I left University of Malaya, and last year, so I went for the 10, okay, for the 10 animal awareness day. I think that human animal, I think we have to be together, and this is how we can achieve, okay, as a one top 2%, so whatever, yeah, okay. So this is the last month one, we went to Sikkim, and this is the end of last month also, I think in Portugal, yeah, about health. They talk about health now. I think everyone now they're concerned about health, isn't it? I think long life. That's why now people stay long life now stay. And this is your conference. Next one is the India one, yeah. And then I have another one in China. And this also next month. You please come if you can join us, okay, for the up course, yeah. And this also in next year, okay. We have next year in India, okay. I think this one in January, this one in March with the proper Mugana, and then May in Portugal, yeah. In September, we have the 3rd International Conference on Natural Products and Human Health, okay. That's a continual conference, okay, from Delhi, okay. This one in Brazil, okay. So I have to thank to the Royal Patronage of HRS, Princess Mahachakri Srinthorn, because of this grant. That's why we can really, explore many, native plants, okay, in ASEAN particularly, and Research Institute for Health Science, Walalak University. I think research integrity is very important, particularly that you're working in many people, but just like our group is about 20 countries, okay? So I think that honesty, responsibility, and transparency, I think is a key for research integrity for me particularly. I really keep in mind of that, yeah. So thank you very much for your kind invitations, and also your, you listening to my talks, yeah. And welcome to Walalak University. We are situated at the south of Thailand. This is my hometown as well. Okay, so thank you so much.
Okay, Dr. Viranut, thanks for your amazing presentation about the role of an Asian native plants against Acanthamoeba infection for the future prospect. And now we have to come to the sharing session or Q&A session, and maybe all of the participants in offline or online, if you have any question, please raise your hand, or you can chat in this Zoom chat. Maybe anyone want to ask a question to Dr. Viranut? Okay, Prof. That was an amazing, yeah. I was interesting when we are talking about nanoparticle. Because my research is focused on nanoparticles too. I developed some nanoparticle which is silver nanoparticle with eco-friendly. So I didn't use NaBH4, but I use some plant extract to keep the size of the particle, to keep it still nano, not an aggregate. And I'm very interested about nanoparticle. And if you can share to me what kind of the nanotechnology or nanoparticle that you develop, Prof?
Actually, that's what I mentioned to you, nanoparticle. That actually, I myself not an expert. I think as you know that I'm a medical doctors, but just because of this kind of technology, really helpful. Okay, really helpful to that extent. But I have the colleagues, okay, junior colleague that he very good in nanotechnology. If you think that you're really interested, you can send the plants, the extract or compound to me. And then we can process for you just like niosome, okay, nanoparticle. He really can do very well. He have so many cell lines, okay, in his lab. Because in Walalak University, we have different, different labs, okay. I have my own lab as a water-based research, okay, just like Akantamiba. And other people may have another labs, okay, just like the person that I mentioned to you about junior lecturer, okay. He will have the lab for the cell line, okay, cell line, you test about cytotoxicity, etc. Okay, so this is the one that he can do. But for whatever I can see, I see that different type of nano actually is good. They have some good and bad points. But when I can see this niosome nanoparticle, I see that this is even much better, Okay, so I think I would suggest to you, if you really want to, you have someone in your own country, yeah, that they are very good in this field. I think you can collaborate with him, with the persons. What I can see is that research is something about collaboration. It's not something about you or me, only one person, Research is about multidisciplinary or transdisciplinary approach now that people really, support, yeah, and really want to be involved in the research. Just like we working with Prof. Mukana, we working with, other, member from Malaysia, So that's why I'm just thinking, if you're really interested, you can send the plans to us, okay? And then we can work out for you.
Yes, that was good information for me, Prof. And based on, I want to ask you about one question more, Prof. Based on your presentation, there are curcuma longa that contain curcumin, and after that mangosteen, and after that Annona muricata, Combretum trifoliatum, and so on. And which one, Prof, that has the most effective activity to fight or to against the acanthomoeba?
Yeah, that's very good questions. Yeah, I think since I work many plants, I tell you, it's the Canima retusa. Canima retusa. It's very good. It is the best. This is the best.
Prof?
Even Canima retusa. That is the plants from Malaysia.
Oh,
yes.
Okay.
That is the best one. Yeah. And my IA now, he is become a junior lecturer. He very happy with these plants. Yeah. Happy with this plant, and you can see the result from niosome is fantastic. It's fantastic. I can't believe this, And suddenly
Okay. Why, Prof?
Why? Because it really can kill the parasite.
Oh.
Can kill the parasites, right? Because the thing that we want, we don't want parasites. Even we know that is they are variable in many sources, okay, resources in the environments. But the one that has become problem to us, become harmful, right? Is a pathogenic, the one that we don't want, isn't it? Right. So when the plants can work wonder with all these, pathogenic parasite, then it's very good to us. Actually, it's very good. So I'm very happy when I present this work. I feel very happy every time. I feel that there is
Yeah.
still hope that we still can see so many plants. Just like Prof. Mukana said, we have tons
Yeah.
of plants, but we still no one really into it. Into it to do it. I'm a medical doctor. I think you cannot really find a high hope from me. I think I should find high hope from you as you are pharmacy persons, because this time you are the one that deal with this, the plants, But for me, I just come and, I just pick up one or two, but I pick up the curcuma longa because I feel that they have some kind of the property that have been, reported before. I'm interested in mangosteen. This just my instinct. Suddenly I say, oh yeah, I think I better go for these plants. But luckily, that's as such only that it's work. It's work. Okay. So Kanima, I don't know it's work well until that we get the result and then we know, oh my God, this is fantastic. So you don't know now. You don't know what's the lie in the nature actually.
Okay, Prof. Thank you for your amazing information, ya, Prof. Ya. But wait for a minute. There is a question from Vita Sari. Yeah. The question is, she is so interested about your presentation on pharmacology, and she want to ask about that natural materials in their development as medicinal raw materials are very difficult. So how is the development of natural materials there as raw materials medicine, and maybe on pharmacology was until in vivo like standard herbs drug, can it be developed from the nanoparticles? Okay, thank you, Miss Vita Sari. Maybe
from this question I think it's easy to read but difficult to answer. I think as a drug wise, you come as a drug, it's very difficult. You cannot just you discover today, you think that it's very successful and tomorrow can make the drug. I think it's not that easy, okay? Because we still have to go through what to in vivo study, right? As the criteria they want, and we have to go for the clinical trial, and that we still not go to that level. That's what I tell you. If right now, what we can do is that I may not be able to go as a tablet of the drug, as a drug per se, but I can do as a just like a therapeutic agent kind of the solutions in street, I think it will be easier to do it. Or otherwise, I can make it as a solution in the animal. Because I think that the logistic in animal is a bit easier compared to humans, yeah. You can see that compared to human, and so many drugs that they use in human, they also use in animals. Yeah. So you can see that there are some kind of a bit what they call, I don't know what to say. Just like it's a reluctance in their own procedure and all these protocols. But I tell you, it's not easy to make the drug, no matter how. I still have long way to go. Way to go. Yeah.
Okay, Prof. Firano, thanks for your answer. How about Miss Vita Sari? I think that's clear, ya, Miss Vita, ya.
Yeah, you can act, but I can tell you not easy. No matter what I say is very good in the lab, but still have so many things you have to do.
Okay, Prof. Thank you for your answer, and wait for a moment. Okay, Miss Vita. And because we have a limited time, Prof, and this is the end of this event, ya, Prof, ya. Thank you for your presentation today, and that was an amazing materials that I have today, Prof. Okay, maybe we can see in another time, Prof. Okay,
Yeah, sure,
maybe
I look forward, Erna.
yeah. Iya, iya Prof.
Collaborate
Maybe
with
in Indonesia or in Thailand. Oke Prof,
Yeah,
thank
you
you.
can visit
Maybe
us,
we
you know.
can give applause
Yeah.
to Dr. Viranot.
Thank you so much.
Okay, to Dr. Viranot and then Prof. Mogana and then to all of the participants today, thanks for your attention. And this is the end of this International Conference of Pharmaceutical Science, Research and Practice 2002. And thank you and see you in next time. Okay, wassalamualaikum warahmatullahi wabarakatuh and good afternoon to all of you.
Okay, thank you.
Ini di end ya. Prof. Mogana still here. Lu hilang. Oke, Bapak Ibu, ini tadi sudah ya untuk acara internasional conference-nya sudah berakhir pukul 14.40 sesuai rundown seperti itu. Kemudian akan dilanjutkan ke acara PhD sharing session yang akan difasilitasi oleh UCSI dari Malaysia. Mungkin nanti di grup akan kami share link seperti itu ya, sesuai bidang minat masing-masing Bapak Ibu. Jadi nanti akan dibagi menjadi beberapa breakout room sesuai bidang minatnya Bapak Ibu sekalian. Mohon ditunggu sebentar ya. Bapak Ibu yang ada di ruangan mungkin bisa sambil join nggih di Zoom, karena yang dari UCSI sepertinya sudah mulai bisa diakses. Untuk linknya ada di grup MOU Rakor Regional 3 APDFI.
Bapak Ibu sekalian, boleh ikut join saja karena mungkin Bapak Ibu kan sebagai top management ya, sehingga tadi kami sudah bincang-bincang dengan pihak UCSI, banyak sekali sebenarnya program-program yang bisa ke depan Bapak Ibu rancang setelah MOU, dan kita sebagai awalan sudah mencoba dengan implementation agreement. Ini harapan kita nanti kampus Bapak Ibu bisa menjadi mungkin leading lah ya, terutama dalam SDM. Jadi mereka punya program sangat banyak terkait dengan biaya. Satu hal lagi, mereka adalah QS ranking. Jadi kalau dari sisi perguruan tingginya, rankingnya sudah bagus, perguruan tinggi dunia, tingkat dunia. Top 1 untuk PTS ya. Jadi kalau di Indonesia mungkin kita baru ranking 300-an lah ya, paling itu kita di sana sudah 284. Jadi sangat tepat, cocok untuk pilihan. Tadi kita sudah bincang banyak sekali. Memang nanti boleh ditanyakan tentang tuition fee ya, terus bahkan tadi mereka sampaikan